If I may ask you to come back to the room and sit back down. I was thinking of doing it at the end. Because I have another announcement to make at the end.
Okay.
All right. So we have the last session of the day, which is about SDMX and interoperability with other standards, which has been already a theme we touched upon in several other different sessions. This session is chaired by our colleague from the ECB, Ole Sorensen. And it will be the last session of the day. It's foreseen to end at 6:15, but okay, we have a bit more leeway on when exactly it ends since it's the last session of the day. Just one point, I mentioned it at the beginning of the workshop. In your printed program, there is one presentation missing for this session. It is a presentation by Pedro. So you will find it on the online program, but it came too late for the printed program. So just be aware of that additional presentation at the end. And with that, I leave it to Ole.
So, good afternoon, everyone. As mentioned by Luca, this is the last session of the day, so we don't really have any time constraints. So I know that when I'm alone in the room, we stop. And I'm sure that when you're done here, I will not be saying good afternoon, I'll be saying good evening. So, I've not been introduced yet by anyone, so I'll just introduce myself. Some of you know me, some of you don't. I started in the National Bank of Denmark in 2001, and before that I did work in other private financial companies. I worked with SDMX for a little over 20 years, not 100% every day, but I've been involved in different projects over the last 20 years with SDMX. And actually one of the first things I did when I joined the National Bank of Denmark was I was supposed to write a Jesmis reader and a Jesmis writer. And here it comes, in Visual Basic 5.0. I don't know if anyone you know what that is. But if we ignore performance, it was good. But ignore performance. So I joined the ECB in 2016 in the statistical application and tool section, and I also been 1 year in the OECD and a few months in the Central Bank of Ireland. You see the first slide here is my small train. It says SDMX BRL. It used to say SDMX ML. I got it in 2009 when I was in OECD. And later I was involved in a paper with the interoperability between SDMX and the data point model. And then I got rid of the M, and then I bought the BNR, and then it became SDMX BRL. But I actually miss a little bit the ML, so maybe I will change it again. We have these 5 presentations today, and now you see the title of the last one that came in a bit late. And these presentations will focus on interoperability between the data point model and the SDMX. Sorry, on here. And we have one that is about the awesome list of statistical tools. Now it is fooling around here. And we have one presentation that explores the mutual benefits with a high degree of interoperability between the SDMX and the semantic web standards may bring. And we have one presentation, which is the last one, the constraints at technical architecture level to enhance the interoperability in the stat suite, the FMR and NSIWS, which I do not quite know what is, but I will know after today. I will introduce you to the presenters as we go on, and since we don't have any time constraints, I might allow a few questions after each presentation, and then also we can do something at the end when it's evening. So if you, Olaf, he will be, you have a local hero, Olaf, he will be the first presenter. I will just introduce him. What I'll do it here. So, the presentation from Olaf is a collective outlook that all the statistical landscape. So SDMX plays a role of growing importance in this landscape, but it's not the only standard in this mix of content, and thus must work together with other standards to yield an optimal, fair end-user experience. I'll not read the full, but the bio from Olaf is that he's a project manager at the Statistics Netherlands with a background in theoretical computer science and a PhD in electrical engineering. He works in data-intense and international standardization projects on statistical open source software, metadata standards, data visualization, data validation, web scraping, and subjects such as energy and air quality and open data. Olaf has been a member of various international standardization groups and ESS innovation projects on these topics. So the floor is yours.
Thank you, Ole. You can all forget about that. It's today about the official statistics landscape. Good to be back. I was away from the SDMX community, especially physically. The last time I was in this meeting was before COVID. And every disadvantage has this advantage. So I thought maybe I can give a little bit of an outside-in view on SDMX. So that's the intention of this presentation. SDMX in a fair official statistic landscape. And I did this work with my colleague Edwin de Jonge, who is a brilliant methodologist, but also implemented a lot of software, open source software, R, Python, whatever, and also in dissemination. And my other colleague, Henk Laloli, and he is a linked data specialist. And he is actually retiring. So the last year I was trying to get as much as possible knowledge out of him, that at least one person in our office knows a little bit about what he did. And I learned a lot about linked data. And this session is about SDMX and other standards. And to be fully honest, the work I did was actually for the conference, the EUROS. There's, with a different title, Access to Official Statistics from R, so that's the R perspective on access to statistical data. 1 year ago, actually. And later on the Cosmos conference, and a number of you were at the Cosmos conference, on fair metadata, and that was the perspective of metadata in official statistics. So now I will put on my SDMX glasses and look at the same landscape. What is the official statistics landscape? I'll try to explain in a minute. Open source. So I'm also the maintainer of the awesome list of open source software for official statistics. Long name, I will show you. The software that's around in the landscape has certain features which we might not completely know. We dive into them. And then a little bit knowledge on the linked data that I got from my colleague, and a little wrap-up. So that's what you're here for me. This is our website in Statistics Netherlands. Screenshots from the website, and we have a kind of a layered architecture, as many of us. We have a fancy website with beautiful design. Okay, judge yourself. With communication issues, good language, descriptions of what happened. And people can dive deeper on the thematic pages, reading articles on a certain subject. Here it's about inflation, and visualization, of course. And they can even dive deeper, click on links, and then they come on selected data slices, so tables. We are coming to the data now. And they can dive even deeper into a database, our statistical dissemination database. And these days, and especially in this room, I call them statistical estimates because you're all very statistical. Of course, our communication department calls them statistical facts. That's easier for the general public. But being also a methodologist, every figure we publish is an estimate. So we have a database of statistical estimates. We are not the only one. Oh no, this is about the database. It's huge. It was already mentioned by my boss, Marit Smekens, in the beginning of this conference. It has a lot of tables, billions of estimates. It's all public available for many, many years. You can search, select, filter, download, rich metadata. It's not SDMX, and we are going to move it to the .stat system on our way to SDMX. But it has already API. It's OData based. And it has software around, which I call convenience packages for our Python and R public. We are not the only one. Almost every statistical office or statistical organization has something like that. So in Europe, we have the Stadbank from Denmark. I didn't see anyone from Denmark. We have Stadline in our country. We have Genesis Online in Germany. And we have Istat, Alessio, Dario. It's called the Idelstat system. Almost every country has a dissemination system with structured data and metadata. And we're not the only one, of course. The sponsoring international organizations have statistical data. And the official statistics landscape, it's what I came up of saying what's there. That's all the statistical data that we produce together. And where a data scientist, a policy analyst is interested in. So the official statistical landscape is the collective output. And this user, it was mentioned this morning, I think, the user is not mentioned, well, it's mentioned here, wants to have our data. So it's actually very simple. In this conference, I would say we'll just put SDMX in between, isn't it? End of presentation? Okay. But I dare to put also a question mark there. I'm not completely sure that this is the case. I'm actually completely sure it's not completely the case. And if it is the case, is the user then completely happy? I don't know. Okay. Let's look at the landscape from a total different perspective. And that's the perspective of the software around us. The software that we usually do not produce, but the data science community produce to access our data. Well, as I said, I'm also, with some others, and actually with the whole community of statisticians, the maintainer. I'm the maintainer, let's say, but everybody helps. It's a community approach to maintaining a list of open source software that's used in the production of official statistics or the access to official statistics. It's called an awesome list. The developers in you that have a long history on the internet might know the awesome concept defined by Sindre Sorhus. That's a famous open source developer. He had to remind so many things. He thought, okay, I can write it down for me. I can put it on a GitHub account. That's better, a repo, and then everybody can help maintain this knowledge. This is exactly what we do here. So after the Statistical Data Editing Conference in the Netherlands, the UNECE in 2017, we had a lot of interesting presentations, as it happens in this kind of setting. But when you go home, you go to your work, it's difficult to remember what's there and to tell it to your colleagues. So the idea was, let's create a common list with all the software that we have to remember. That was the beginning of the awesome list. So it's maintained by the statistical community. So once in a while I get change requests. It's on GitHub, so we use the change management of GitHub. You can like it. You can go there, awesomeofficialstatistics.org. Click on the slides if you want, and you are there. And you see that a lot of also SDMX software, which is open source, only if it's open source, by the way, you can come on the list. And it has some maturity needed. So please make good releases. Okay, this is the GSBPM that we have. Probably everyone knows the process steps that you can see if you make statistics. And one of the bubbles indicate the open source software on the list, where they are located on the GSBPM, and the largest category is actually access to official statistics. In GSBPM, it's named a little bit different, but okay, give me some freedom. How does it look? It's just a list of a one-liner describing what it is, a link that links directly to the place where you can download the thing to get it up running as soon as possible. And some batches, and the batches are auto-generated from the repository where the open source package is hosted, either GitHub, GitLab, Cron, or PyPy. So this is all automated. And I just looked up the Travis, the last change on Travis was yesterday as well. So it's actually... for instance, this is the category statistical disclosure control, well-known packages that are used by many offices. There are others, I won't go into that, because the subject of this talk is the category access to official statistics, which starts with the package RSDMX, which is a kind of a bridge between the R community and the SDMX community, or the SDMX generating community. Read SDMX, SDMX simply called the Python package, and if it's mature, PySDMX, which was presented earlier by Xavier, of course. But also others. In the in the JSON stat community, there are also packages to access other databases. So it's a way of looking at the same landscape from the user. And you see it's not only a standard in between, there's actually a lot of software in between. And some of the software packages use SDMX, and some don't. So the challenge was to get a better view on this landscape. And what we did is create this table in end of 2023. It's online, if you want to have a look at it. Look it up. And if you have changes, then please send me mail or whatever. But it lists the data providers that were all the data providers that can be reached by all the software on this list, about 60, and the packages horizontally, and the standards that are used in these packages. And this was generated by reading documentation or running the packages if possible, because it's not always known which software gives access to which data source. And what you see is a few standards popping up: JSON stat, OData, PX, SDMX, and others. And if you look at it with a colored glasses, then you see that the world is a kind of disjunct world into SDMX, yellow, and JSON stat and PCXs. A lot of you might not know it. That's the other part of the landscape. It's almost disjunct. So offices use either one or the other. And there's one little statistical office that uses another standard. That's the red part, that's us. We chose OData long ago, and we were the only one. Well, not completely the only one. Long ago, the OCD.stat system also supported OData, but that they went to SDMX, and now we will go to the yellow world. I'm happy to say it in this conference. You can also look in a different way to this table, and that's vertically. And then you see that there's software that's actually more standards-based, like RSDMX, I mentioned it already, and Read SDMX, and also in the JSON stat world, the PX software, that you can use to get access to many different databases that use this standard. That's great. That's the advantage of standardization. So that's the reason I say RSDMX and Read SDMX and maybe others is bridges the two communities. But you also have data provider-centric packages. They give very detailed access to a statistical database of mostly one data provider. Inaki, one is somewhere here, has an R package, or someone made an R package for accessing your database, Inaki R. Another one for the ABS, Statcan has one, Yorstat has a very good one, maintainer is not here. Yeah, I've seen people in the R community demonstrating that package, and they were not the author of that package, but they were the user, and they were enthusiastic that they got all the data from the database. Question later. Okay, the third one is what I call aggregator sites. You also have software that gives access to a data source that actually uses the official statistics of other data providers. RDBnomics, I don't know how you pronounce it, is an example for economic data. And the IPEM is an example for survey, census and survey data. And they do some harmonization layer. Okay, I hope you still follow me, but the landscape is a little bit more complicated, let's say, than you see at first sight. That's the message. Okay, and then we said fair, you know, all fair, findable, accessible, interoperable, reusable. We all want to be fair. And principles, you know, it's not quantitative enough, but it's principles. So to say something about the fairness of the official statistics landscape, we again had a look at all these software and say what features can we find in them. So I identified some features, and one of them is endpoint hiding. So what do our users want? Not having to remember this endpoint URL, but just say Eurostat data, OCD data, IMF data. Endpoint hiding. Catalog retrieval, having a query, what's there? What's there? Search. Over a dataset, in a dataset. Queries on the endpoint. Think about the API Xavier presented. Local queries. If you have your data, you can maybe want to query locally on your dataset. It might be huge. Caching. You don't think of that first way, but if you have a software layer that does the caching for you, yeah, then you just program your access to the database, and the software intelligently handles the round trips. Integration with cartography and registries. Okay, this goes a little bit too far, but we thought that the landscape is quite findable, also accessible. Interoperable is a little bit weaker, and reusable. Cartographic queries wasn't supported that much. This was without SDMX. Now I put on my SDMX glasses. So I said, okay, endpoint hiding. That's interesting, because there are at least, I'm not complete, 3 pieces of software that do this. The RSDMX maintains a list of endpoints. SDMX endpoints in itself. Xavier also does it in his package. And the SDMX1, or SDMX, how you call it, also do it. And they have even an automatic testing of the endpoints. This comes very near to the very good presentation IDs and implementation that Stratos presented, because what we do here in the next step is taking the list out of the software packages and maintain it with the community. That's a good step. And actually the ID was mine. 3 years ago, Stratos mentioned it. So we're doing well. Catalog retrieval, doing better and better in SDMX, I think, with all the new queries. And subset slices, yeah, that's a strong point, I think, with the API. And I quote here the cheat sheets. So the TWG has its repo with the cheat sheets for 2.1 and 3.0 and probably others, but I have to explain it to so many people. Please put them on front on the SDMX website or somewhere. Can I say as a user? Okay. Now a complicated point, registry access. I think this is also a very strong point of SDMX. We have a global registry and we have other registries in the organizations. And the registries allows for structured access to metadata. That's important if you have to report your data to an organization, but also for discovery. In 2021, during COVID, I had a presentation online about connecting to the registry with our validation software. Not VTL-based, but R-based. Validate, R-validate. And we used this glue package, RSDMX, to access the code lists and program a high-level function where the R user in an R way just can say, validate my data against this DSD, which is in this registry. Of course, it has to identify the DSD or the code list. And I think this is also a possible strong point. This is R. But the Pi SDMX that's being developed, I heard it also has some pandas integration. What we do then, we don't enforce SDMX to these communities. No, we bring SDMX into, or we bridged with the tool set they already use, if you follow me. Okay. Still have time, Ole? Good? Okay. I don't know. So that was the landscape. What about linked data? So my colleague just mailed me yesterday that he has an extension for a year, so I have more time to get all the knowledge out of him. In the Cosmos paper, we wrote quite a section about linked data, and we had a view at the Eurostat system, but Luca will present in an hour this, I guess. Eurostat uses the Europe way of doing linked data, statistical metadata in a linked data format, which has some advantages for the linked data community. We had a look at the Scottish dissemination system, which is completely linked data based, as we saw it, with linkability on the observational level. Quite interesting, a bit slow. And our own system made by my colleague, vocabularies, taxonomy, very extensive, and using all the linked data constructs to model metadata. So not SDMX, linked data. And he also created a knowledge graph. I will come to that. And one of the advantages we see there is that using linked data, you can easily link concepts, constructs within the ESS, within partners in the ESS. So we have an example of linking our NETS 1 areas to the Eurostat definitions, or back, but it's probably more logical to link to them in a linked way, or a link to communities outside of the European statistical system, like the Wikidata, where there are, I don't know, volunteers maintaining a lot of knowledge on the Dutch history of municipalities, let's say. It would be so good to have your statistics linked to this community metadata. We can do that with linked data. So that's a strong point. But it's maybe a little bit more complicated. So if you really want to go in, send me a mail or read the paper or whatever, our conclusion, and we'll keep it on that level, is that linked data is well suited to link across ESS and non-ESS communities, where if we use a ESS standard, SDMX saying it's our standard, then it's more within the community. So that will be a strong point of linked data. There's another thing. In linked data, you have, Luca mentioned it yesterday, I think, on the presentation of MAT, where you had the UK member and non-member of the EU and all kind of organizations, which is also possible in linked data, of course, maybe even better possible. So my colleague did this. He modeled a complete historical graph of Dutch geo changes, and now you have to know that in the Netherlands we are very well organized. We are so well organized that we change this every year. So the changes on municipality level for over 2 centuries, and this is really a big graph. He could do this in linked data, and then you can query in Sparkle. So I'm a bit, okay, that's a strong point of linked data. There are also challenges in linked data. It can be perceived complex to end user. It sure can be. So if it's set of SDMX, linked data as well. And what they then do is create data storage, and that's something like example queries, explaining, and people can manipulate the example queries and in that way understand how you query linked data. But it can still be complex. And the more flexibility you have in your model, the more open the model is, the higher the chance that you have different implementations. We already have a different implementation. Eurostat and us in the 2 systems. So my linked data specialist saying, no, we're not using XCOS because it's too specific for a specific community. I want to use the general constructions that everybody knows in the linked data community. So this is already a difference. The more flexibility you have in your modeling, the chance higher that you create difference, then you need harmonization. And then, I'm almost there. Food for thought. In the beginning of the conference, we talked about AI a lot, looking at Jeff, and trying to make intelligent chat engines on our databases and on our metadata. The other way around is friendliness, as Luca already said. I will put it a bit stronger. If I could dream, I have a lot of dreams, this is one dream, I would wish that every chat engine there prioritized our high-quality statistics over all the garbage that I have on the internet. So I would enforce our content in the chat engines with a high priority to feed the AI scrapers, let's say, with our statistics. And then you can ask yourself, should we have our content in SDMX or linked data or something else? I don't have the answer. If you have the answer. Okay. So, concluding. The user is very happy. We use a lot of standards, actually, more than I mentioned already. We are partly open. We have a layered architecture. We also have restricted data. We have external researchers working on our microdata, not to forget. We mix our standards. That can be complicated for users. Identifiability is one of the criteria of FAIR. Identifiability across standards is a thing. Note the software layer around us. It's not only us, but people create software to access our databases. Might be interesting to be aware of that and look at the features. There are communities around us. There's a paper from someone from Groningen University, Frans Willekens, who wrote an excellent paper of accessing demographic data in our statistical databases around. It's worth reading. Okay, so the landscape. There it started. The landscape rose towards standardization, a few flavors. SDMX is a strong one. There are a lot of software around us. A lot of organizations offer, or the community creates R packages because the R community wants their data easily in an R environment. There are some common features. And about dreaming, there is no one-for-all software package at this moment which I can use to access all statistical data providers on the landscape. If we ever come there, that would be great for fairness. Thank you.
Thank you, Ole. I think I would need to cross-check your list of tools with SDMX with the one that we have on the new tools page to make sure that we have all of them. Any questions? I mean, one or two questions can be allowed, I think, and then we, yeah, Abdul?
Yeah, thanks, Olaf. My question to you is this. So you gave a perspective from CBS, but you did a landscape. And when you combine your own point of view with the information you got from assessing the landscape, what do you think international agencies like Eurostat, OECD, the United Nations, what should they be doing that they're not doing yet? What would you like to see in this context to improve the landscape?
I think two things. Standardization is good. And standardization is also not trying to, the standard evolves, and I also talked with others, the standardization is difficult with a lot of organizations. You also have to choose the right things to do that have the most effect and choose not to do other things that might be less important. So go on with standardization. but also talk and work with the communities around us. So the Euros, and I had a picture there where people exchange knowledge and the statistical data editing group, etc., and they work with a lot of data. I hear never SDMX being mentioned in these communities. They were just about data and methodologies, but if they need good metadata. So I would say and not only the international organizations, it's also the national organizations. It's just a geographical difference, because if you are a national statistical institute, you have the same. So standardization is good, but listen and work with the users. And the users are oversimplifying here. The user doesn't exist, of course. I have another slide. I also teach open data to data scientists. And it's extremely difficult to know what are the users. But if you have the chance to talk to users, to get input, and there's also another difficult thing, the satisfied user will not say anything. If they have their data, they have their metadata, they will only come back if they have a question after working on your data for months maybe, and then they have a definition question. So I do it a different way. But I would say, be aware of the communities around us, and please also work with them as much as possible. I hope that's something, and I don't have the definite answer.
Okay, thank you. I think we will take more questions at the end with all the presenters. So thank you, Ole. So the next presentation is from my colleague in ECB, Fernando Wagner, and he's doing it remote, and he will be presenting something about the goals of the new version of the data point model 2.0, also known as a REFIT, and how it can be the interoperability between the data point model and SDMX. Fernando has more than 25 years of experience in the management of supervisory data, and more than 15 years working with XBL in particular. And since 2013, he's working at the European Central Bank in the statistics department. He's responsible of the super system used to collect, process, and disseminate all supervisory data received by the ECB from the NCBs in XBL. He's also responsible for a project to create and maintain a data lake with all data relevant for supervisory data analysis at the ECB. Prior to his work at the ECB, he worked at the Banco de España for 18 years, but always on the field of supervisory data. So, Fernando, you can begin.
Thank you very much, Ole. Thank you. I hope you can hear me well, and you can see also the slides. Otherwise, please let me know. Yeah, I noticed, Ole, that I think the DPN it was not mentioned there, but DPN is very linked to the XBRL, at least for the supervisory work in Europe, and that's why sometimes they are used at the same level, the DPN and XBRL, while they are two different things, and even more with DPN 2.0. So I've been asked to provide a presentation about this interoperability of DPN 2.0. I added there with SDMX because, of course, this is SDMX forum. I think it's more interesting to have a case example of how can a time series be modeled by using DPM. But the point here is that in order for you to understand how to do this mapping, or how to make these two standards interoperable, you need to understand what is the DPM, and I'm not sure the level of understanding of the DPM. So part of the presentation, a big part, I would say, of the presentation is to explain a bit the data point model, what it is exactly. I apologize already because I will get too technical, maybe by far more than the previous presentation, but I hope it is okay. But let's start with a quick introduction of what is the data point model. Okay, well, it started in 2012. It was started to support the supervisory reporting by the European Banking Authority and also by the EIOPA, which is the regulator for the insurance world. Okay, the first DPN model was published in 2013. It was a part of the ITS 2.0 technical package, which is the regulation that defines the supervisory data reporting in Europe. This first data point model included already the first version of the data dictionary with all the elements that it has that I will explain in the next slide. The initial version of the DPN, and I'm talking about the meta model, has not changed, so has been stable for the last 10 years. And then in 2023, the EBA and EIOPA started rethink how this model can have an evolution so that we can cover more cases and also in a better way. So this is what the EBA and EIOPA was doing, and this is what we call the DPN refit or DPN 2.0, as Ole said. But what is the DPN? So this is the first point. So in this chart that you see in the right-hand side, you see that, okay, there are some legal acts that are included in the regulation, this ITS that was mentioned before. This regulation already includes tables. Okay, tables how the data should be reported. You know that the supervisors, it's not that they don't like time series, but they like to see the snapshot of one institution, one entity in one single point of time. Okay, the balance sheet item or whatever. They want to see it more than time series. Of course, they also make a horizontal and time series analysis at the end of the day, but for reporting, they want to get data of all the data available for an entity at one single point at a time. And then they like to do it in form of tables. So in the regulation, there are already tables define how this the reporting should be done. Okay, then all this regulation is transformed into the data point model. Okay, as in form of the metadata. So all this metadata is created based on the information in the regulation, because quite similar to SDMX until now. And then based on this metadata, including the DPN, then the EBA or the EIOPA, they create the XBRL taxonomies that at the end of the day they used for the reporting of the supervisory data to the European authorities. Then, but what does this DPN include in practical terms? Then we have here in the slide. So it includes modules, templates, and data points. So templates or tables, we are using the same word, practically the same concept. So the templates are the ones that are included in the regulation. Of course, they are defined with and not only the data points that are included in these templates, but also the rendering, so how these tables should be rendered as defined in the regulation. Okay, this is included in the DPN and transmitted to the XBRL taxonomy. So not only the definition of the data point, which is the second point that you have there, so the definition in terms of dimensions of each data point, but also how the different data points should be rendered. And then the definition of modules is also included. A module is a grouping of templates, okay, that needs to be reported in one single file. So for instance, FinRep, that is sounds familiar to you, is one module, okay, that is always reported. It's the minimum amount of information that can be reported, in the sense that if there is a correction of one single data point of FinRep, then the full module with the more than 100 tables needs to be reported again as a correction. Okay, and then also of course the data points coordinates. So every data point that we define in the taxonomy needs to be defined in terms of dimension, but also in terms of coordinates. So where, in which cell they are represented. And finally, one interesting thing is that the validation rules that need to be executed to assess the data quality of the data is also defined in the DPN and in the taxonomy, so that the entity when sending the data or the authority when we receive the data, we can execute all these validation rules to assess the data quality. which is something interesting that happens in the XBRL world. Yeah, I mean, the EBA, whenever there is a new regulation, the EBA produces a new database with the content of the DPM. And the XBRL taxonomy, as I mentioned, is the technical exchange of the information. Then this slide is to show a bit that there are several meanings of the deep data point model. Okay, because on one hand, the data model is a methodology, so how to model the metadata, how to model the regulation as metadata in the DPM. It's also a meta model. This is what we are going to focus a bit more today. Is metadata itself. So when we talk about the data point model, sometimes we refer to the metadata that is included in the meta model. I mean, it's published by the EBA or the IOPA, and even a toolset like the DPN Studio that was also created by the EBA. Okay, talking about the new release of the data point model, the 2.0. There are some improvements. The main improvement here is regarding variables. So, curiously, now in the new version of the DPN 2.0, there is not the concept of data point anymore. Even if it's the data point model, they are not data points anymore, but they just a new concept, which is variable. And there are several types of variables depending on how the different tables are modeled or the different concepts are modeled in the DPM. Okay, I will explain this later. But I want to bring your attention. Of course, there are all the things that are improved also in the DPM 2.0, some things that were not included in the first version. But I want to bring your attention in one point that is there highlighted in bold. I have just copied and pasted from the EBA documentation, okay, as one of the aspects that they wanted to improve with DPN 2.0, which is the enhancements of the interoperability with similar standards, and they specify SDMX between brackets. So this is just extracted from the EBA documentation. Okay, very quickly, I mean, this the DPN is an ISO standard. They tried with this new release to adapt the data point model not only to aggregated so very granular data as the supervisory data, but also to aggregated data points. I mean, they are trying to cover more cases. But let's go into the topic, which is the review of the DPN 2.0 data model. And here is when I'm going to get a bit more technical. I hope you can follow me, because I mean I'm going to be a bit fast because of the time. So I hope you can understand at the end of the presentation what is the DPM. So I don't want here to scare anyone with this slide. It's just to show that I'm going to explain 4 different parts of the data model. This is not the full data model. There are more parts. Like for instance, there is nothing about how to store the validation rules here, but I wanted to simplify it a bit. Then I'm going to explain the glossary part, which is the blue part. Then how the variables are defined in the DPN, which is the red part. Then the rendering, which is the green part, and the packaging is how to get the models, how the models are modeled. Okay, let's go with the first part, the glossary. Okay, the glossary includes the definition of categories, that in SDMX I think they are the code lists, the items, which are codes, the hierarchies, if I'm correct, there is a concept that is hierarchical code lists, SDMX, and then properties, which are the dimensions. Okay, these are the 4 main concepts that are included in the glossary part. Some interesting characteristics of the DTM, okay, that's the categories can be enumerated when there is a closed list of values, which is the most typical case, or not enumerated. Okay, a category can define a pattern of data. I think you are calling them facets, if I'm right. Okay, then properties, they can be quantitative. In this case, they are usually measures, or they can be qualitative, and they are usually becoming dimensions in this case. Properties can be applied to tables, headers, or more typically to variables. Yeah, optionally there is a concept of context, which is more used if you want to model actual supervisory data, because it is important for the XBRL to have these definitions of concepts, which is actually equivalent to the definition of data point that we have in the previous version of the DPN. Okay, a context is a combination of pairs property items that define one data point. Okay, this is the context that we are not going to use for our case here, for the use case that we are discussing here. New elements that are added in 2.0 that were not added in the previous version is compound items that are now, there are subcategories that can be created, and the dictionary elements that now can be historized. So you can use a category item, use a property, and at some point stop using it or creating new ones, and then you can define until when or from when you want to use these elements. There are many elements that are historized in the DPN now. Okay, let's go with the second part of the model, which is the rendering part. Okay, here we're defining the tables. Okay, this explains what it is. The headers. Okay, headers can be any column, row, or sheet. Okay, sheet is a set axis. Okay, the set axis that any table can optionally have. Okay, and then the cells. So it is defining also every cell that is included in every table, or at least depending on the type of table. I will explain it. So some interesting characteristic of this part of the rendering, well, tables can be grouped or can be associated with each other. The direction of the heads can be, as I said, row, column, sheet, and then there I have underlined this, that open tables only require columns. I'm going to stop here to explain that, okay, there are two types of tables that they find usually in the regulation. One is normal tables, that they have row and columns, and optionally sheets. And there are other kind of tables that we call them open tables, that they don't have rows. I mean, they have columns, and there is a variable number of rows. Okay, and then there are some of the columns that are key columns, okay, that define the rest of the, identify the rest of the values that are reported in the other columns. Okay, you see that this is already getting closer to the SDMX if we think of this these key columns as dimensions and the rest of the columns as measures. A cell can point to between 1 and 3 headers. Okay, one cell can have 1 header if it's an open table, or 2 or 3 headers if this is a normal table. Okay, a cell can be mandatory or excluded, which is something that is also sometimes the regulators, they are very imaginative, and then there are some cells that specifically they don't have to be reported, so this can be mentioned here as excluded. And finally, a table can be broken down into several abstract tables. As I said, the regulators are imaginative, and sometimes they define tables in the regulation in a way that is very difficult or even impossible to model in the DPN. Then they can be split in several abstract tables, okay, so that these abstract tables can be modeled in a different way, but still belonging to the table that is in the regulation. And then as new elements in the DPN 2.0, here I highlight the definition of key variable. Okay, this is something completely new that didn't exist before, and this is what gives now a lot of flexibility in terms of operability of the data point model with other standards of kind of modeling the data. Okay, to other ways. Then, yeah, I will explain it a bit more what is the variables in this slide. Okay, here we have that there are 4 types of variables in the DPN. There are fact variables that we can link to measures in the SDMX, and there are key variables that we can identify as dimensions, okay? And then we have the attributes. This is new in the DPN 2.0. The attribute variables are called that they are actual attributes. And a file indicator, this is something very specific. So this is a construct to define what templates are included in every module that is reported. Okay, and this is something very specific for the supervision business. Then some interesting characteristic of this is that a variable must refer to a property. Okay, any variable has to refer to a property. A variable may at some point refer to a subcategory mainly if it's a fact variable or to a context. The composition of a variable may change between releases. Okay, this is a bit cumbersome because if you imagine you have a variable and you have it has a dimension with a code, in this case, talking in terms of SDMX vocabulary, and this changes at some point. So it's a bit weird, but this is the way that the EBA has decided to model things, and then the DPN allows this. It doesn't mean that you need to use this way of modeling the things, but the DPN allows that this happens. Then the fact variables are provided to cells as intersection of the header. So you imagine a table, you have the rows and the columns and the sheets, and then the intersection of the three is a fact variable. Okay, this is actually what is reported. Okay, these fact values are what actually is reported. And then the key variables are derived from the headers that don't have cells. So you can model a table without any cells, just have columns, and the columns can be key variables, in this case dimensions, or can have fact variables, which are the measures. So you can already hint how the interoperability can work with the DPN. Okay, then finally, this I'm going to be quick. This is the way of packaging the different tables. As I mentioned before, modules is actually a file, so it's actually the minimum amount of data that can be transmitted, and each module can have usually have several tables inside, and modules can be also packaged into frameworks. I mean, not packaged, but there are frameworks. Each framework can contain several modules. For instance, FinRep is as framework is also a module. It's only one module in the FinRep, but for instance, in CoRep there are several modules. CoRep would be a framework. There are several modules: CoRep of funds, CoRep leverage ratios, CoRep large exposure. So there are several kind of CoRep modules that are all of them in the same framework. So framework is something is a regulatory requirement altogether. Okay, then. Maybe I was a bit fast, but as I said, now the interesting thing is in this slide, which is an example of usage of the DPN with SDMX. Okay, so in this case, I have chosen a time series that is an exchange rate. Okay, data set is an exchange rate and has the dimensions that you see in the screen. So frequency, currency denominator, exchange rate type, and series variation. Okay, this is the definition of the time series with the codes that you see there. Then how I would model this in the DPN. In this case, so every dimension would be a property. Okay, plus the data set should be also become a property, because otherwise we could model only one time series in the DPN. So if we want to model several, then we need to add this concept of data set as a property. Okay, so that we can include many time series in the same DPN. Okay, and then apart from this as well, I would model the period as a property. Well, value is to be a property. I haven't mentioned before, the property can be, there are like two kinds of property. I think I have mentioned before very quickly, but I will mention it a bit, explain a bit more now. So property can be a dimension or can be a measure. Then the difference is that the metric, when the property has this is metric attribute to true, usually is a measure, and when it doesn't have this to true, usually is a dimension. I say usually because it can be modeled in different ways, okay, and it could be that this metric is false and it's still a measure, but yeah, usually this is the case. Okay, then all of these blue arrows that you see, they would become properties, okay? The difference is that some of these properties would become a key variable, and there is one, which is the value that is actually a fact value. Then how I would link this fact value to the key variable? So with this all 1, 2, 3, 4, 5, 6, 7 key variables, I can create a key ID, so a key composition, a composed key with all these seven key variables that would be linked to the actual fact value. I didn't want to add too many tables here in order to simplify a bit and explain a bit more didactical, but you can imagine that the variables, they are linked each other. Okay, so you can link one variable to another variable. Then or you can link a fact variable with a composed key variable, which is the case. So with these seven, the key variables that I have defined here, you can create a key composition that is linked to the fact variable to univocally define what of each one of these values mean. Okay. For that, as I said, we need to include the period as a key variable also. Yeah, and finally, I haven't mentioned, but of course, the codes that the dimensions take, they would be items in DPN. So, as a summary, so how I would model, the first point is a bit, I mean, each data structure definition can be represented by whatever. I mean, you can, depending how you model, can be a table, can be a set of tables, can be a module, or a full DPN. I mean, it depends how you want to model the data structure definition. Can be, for instance, typically a module could be, or a group of tables. The code list would be mapped to categories, or the codes would map to items. If you have hierarchical code list, and they are mapped to subcategories in DPM. Then the dimensions are mapped to properties, as I said, that become key variables. Okay, so each variable would be linked to one property. Measures are mapped to fact variables, and then finally attributes. In this case, in this example, I don't have any attribute. You have the observation status as an attribute, and it would be mapped to an attribute value in this case, and then this attribute value would be linked to the fact values. And this is the explanation of how I would model this in this way. Then I brought another example, which is the usage of the DPM as entity relation model. So you have a typical database that is normalized. Okay. In this case, for instance, I have there 4 tables. Something very, very basic, just to explain how it would work. Okay. So you have to go with all the persons and then the role of each person. Okay. Then how I would model this? This is to show that any database can be potentially modeled into DPN this way. So I would model this that each one of these entities, entity relationship, they are tables. They would be tables. So we will have here, in this case, 4 tables: person, role, author, and owner. Each one of the columns would be a property. If you see in the person role, there is only one column defined as a property. It's not that the others are not, it's that the others are the same properties as the first column. Okay, it has the same, it's the same concept. Okay, so all the columns will be properties. But then every table have a primary key. Okay, how you define the primary key is by the header. So you can think of that each table like is an open table with columns. Okay, some of these columns are the build the primary key, and then this would be defined with these header tables. In this case, it would be all columns, and some of them would be key, and some of them they would not be key, and they would be normal columns. And the same for the person role table, for any other. Okay, there is a way also defining the association between the tables. Okay, you can define 0 to many, 1 to many, many to many relationships with this table association. So this is included in the definition of the DPN and explanation and documentation of the DPN. Okay, and and then we need to define finally that these values of the primary key, they are not null. Okay, this is just a side thing. Okay, then all the property again, all the columns of the tables, they become variables. Some of them become key variables, some of them become fact variables, depending if they are part of the primary key or they aren't. Okay, and this is the way that any entity relationship model can be modeled in DPN. Okay, final section very quickly is the usage of DPN by IREF. I hope you have heard about IREF. This is an initiative that we have in the ECB. It means Integrated Reporting Framework. We are trying to replace all the statistical collection that we have by just one collection, very aggregated, and then we take care of the aggregation. It's, very simple explained, but something like this. Okay, but then this IREF, they assessed the usage of the data point model as a meta model for the IREF metadata. Okay, and then what the run is a proof of concept of whether the DPN is valid for the IRF or is not valid. Then with this proof of concept, they try to model the IRF concepts into the DPN. Okay, then at the end, they study what is the structure of the DPN, has the ABA is popular entities, and then try to bring a use case, okay, for the Autoscope is the tools and the integration into environments. So it's just to check if the model is good enough for the IREF or not. Then the conclusion of this proof of concept was that DPN refit is valid meta model for covering the IREF requirements, that the proof of concept was performed using the approach of modeling the DPN as entity relationship model that I have just explained to you. So this is the way they would model. They would model IREF using DPN. And the main condition is that there is a governance model needed to be put in place for the DPN. Okay, so that if IREF start using it, that there are no changes to the DPN 2.0 model without our supervision or collaboration, contribution. Okay, additional considerations is that the modeling approaches uses that the EBA are different, so it would not, as you have seen, it does not the same modeling approach as used by the European Banking Authority for the supervisory data. The IT solutions, consequently, cannot be the same also. And for now, there are no semantic considerations that have taken into account when analyzing it. And here I stop. I think it's more or less half an hour. Ole, back to you.
Thank you very much, Fernando. Very nice. I think we will take Fernando's questions now, because otherwise you will, I don't know if you stay until the end. You will not here, so you can probably do some other work if you want.
As you like, Ole.
You will stay to the end, or?
If you want me to stay, I can stay, no problem. I can work at the same time. So.
Okay, we'll take some questions now. Any questions for Fernando? Yeah, Matt. Oh, Jens. I thought it was your. Okay, sorry.
Sorry. Yes, thank you for the presentation. My question is more on the business case of this data model. It was done after SDMX started, and ECB is a sponsor of SDMX. So my question is, what was the specific business case for developing another standard besides SDMX? So yeah, in order to understand the motivations to invest in something in addition. Thanks.
My question is, do you mean for supervisory data?
Yeah, about the data point model. So it is it is a model. It's an approach to model statistical data, as I understand, which is very, very similar to SDMX, as you explained with the similarities and how to map and things.
Okay. Yeah. Here the point is that we are not directly using the DPN when collecting supervisory data right now. What we are using is the XBRL taxonomy. So coming back to one of the first slides. So here, what we are using is the XBRL taxonomies, not the DPN directly. Okay, and this is mandatory in Europe. So it's something that is imposed by the European Banking Authority and the European Commission. Okay, that the XBRL needs to be used for the supervisory reporting. So it's something that we didn't choose at the ECB. Okay, as I said, the XBRL is very linked to the DPN because the EBA and the IOPA, they use the DPN to model the XBRL taxonomies. So you can imagine our modeling here is very close to the DPN. So at the end, if you use XBRL for supervisory data, and the modeling of how the XBRL taxonomy have been done, they are very close to the DPN. Okay, so this is something that we didn't choose on our side. I was asking if you are referring to supervisory data, because this is the case, what I have just explained for supervisory data. For IREF is something different. For IREF, we had two different options. We had more, okay, but in principle, DPN and SDMX. And the people in charge of IREF, they thought that with the new version of the DPN 2.0, they have more flexibility to model the IREF concepts. And this was the reason, I think, why they chose to use DPN. I hope I have answered your question. Otherwise, please.
Any other questions?
Yeah. Thank you for the presentation. Just a quick question on the versioning. So there's DPM refit and DPM 2.0, and unless, or what I've been informed, or this may or may not be correct, is there's a new version that's going to be submitted to ISO, which is being done under Workgroup 5 of TC68. Is that DPM 2.0, or is it something over and above that, or is this like a draft for the submission to ISO?
No, yeah, exactly. So currently, in the version of DPN that is in ISO is the previous version of the DPM. Okay, with the DPN 2.0, what we want is that this ISO standard is updated, because the changes in the DPN with the DPN-0, they are very radical. Okay, it's very, very different, DPN 2.0 to DPM. So as I said, there is not the concept of DPN, the data point anymore, but it's now variable, and there are several types. It's very, very different, and that's why we want now to. There are several group of authorities that they want to update the DPN ISO version to this new DPN 2.0.
Okay, so the work is complete. Is that correct? And this is ready to go to ISO?
The work of the DPN 2.0, yes, it is complete. Yeah.
Okay, thank you.
Okay, any other questions? No? Okay. Thank you, Fernando. Thank you for the
Thank you very
presentation.
much.
So the next one, sorry. The next one is Luca from Eurostat. He don't need any presentation. He's been presented many times today, I think. And he will do a presentation that explores the mutual benefits that a higher degree of interoperability between SDMX and semantic web standards may bring. So, yeah, the floor is yours.
All right. So, hello everyone. My presentation today is basically a long way to have a question to the room about the kind of interoperability or integration that we think we should have as an SDMX community with the semantic web standards. And it's very good that Olaf's presentation was before mine, because then I have to spend less time explaining some stuff because Olaf already covered them. What am I doing wrong? The big green button, yes. I was pressing the small red one. All right. So SDMX and the semantic web. You may or may not be aware of the concept of semantic web. It is a concept that was created, let's say, or first described by Tim Berners-Lee, who is one of the people considered to be the godfathers or grandfathers of the internet. And his idea is quite simple. You have an object, some resource that you want to describe. You give it a URI, an HTTP URI, URI being a unique resource identifier. When you go on the internet and look up that URI, you get some useful information about that object. And that useful information is in some sort of a standard. And you link this object to other objects, right? This is basically what the semantic web, what the idea is with the semantic web. I have persistent identifiers for certain things without defining them better. These things have properties that link them to other things with persistent identifiers, and all of these properties and information is in some standard format. And so it's a concept that's been around for a long time now. I think this kind of definition of semantic web dates back to the early 2000s. And the reason that, or one of the reasons that there is a lot of talk about the semantic web is that there is a close link with the FAIR principles that were also mentioned by Olaf, right? The FAIR principles are a set of principles about how you should publish your data to be open, well, to be fair, findable, accessible, interoperable, reusable. Now, the principles themselves are principles in the sense that they don't tell you exactly how to do it. They don't give implementation guidelines. And you don't need to go towards a semantic web to be fair. But if you have a semantic web implementation for your data, and you do it more or less well, then you will be fair, basically, right? So you can be fair in other ways. And actually, I will show at some point that even SDMX is fair in many ways, but not necessarily in all ways. But going towards linked open data definitely can make you generally fairer or more fair. And the question is to me, okay, we are the SDMX community. There is this other community around the semantic web that has its own standards. Before we even think about how to interact, the first question is, why should we interact? Should we interact? I mean, is there a business case here? And I think you can look at it from 2 points of view. We can see, okay, what can the semantic web do for us as SDMX, and what can SDMX do for the semantic web? let's start with the first question. What can the semantic web do for SDMX? And for me, at least at face value, the first thing that the semantic web can do for SDMX is increase the findability and discoverability of our data. I can give you a couple of examples where the semantic web it tries to increase the findability and discoverability of data. The first one is the data portals that you have at EU level, probably also beyond the EU, but at EU level, each country has a national data portal where they're supposed to make available all kinds of data produced by government authorities. There is one similar data portal for the EU institutions, which is the one I'm showing here, the EU data portal. And all of these EU data portals work on the basis of the semantic web. So the information, the metadata about the data sets exposed there follow a standard that is called DCAT, which is a standard created for data portals. It's an ontology created for data portals, and it's all based on the semantic web. The same DCAT ontology, I will say something for those of you who work in the EU. You may have heard about the concept of European data spaces. It does look like, even though no firm decision has been taken, the same DCAT standard will be used also for the European data spaces, which would increase, let's say, its importance and the importance of the semantic web within the EU in the context of these data spaces. But beyond these government-led initiatives, there's also initiatives on the private sector that try to leverage linked open data. And one interesting one I want to mention here is the Google Data Commons initiative, which is based on the schema.org ontology. Maybe ontology is not the best name for schema.org, but in general, it is still based on the semantic web concepts. You have objects that are identified by URIs with properties described by this schema.org, these schema.org properties. And you can go on Google Data Commons, and you have data from several organizations. You make a search, and it gives you some results. The results are not necessarily very good, to be honest, for now. But it's there, and it's something that many people know of because it's powered by Google. It's there, and people use. And it's something for us to be aware. If we want to be present there, then we need to have some sort of interoperability with schema.org. And Olaf had raised a very good question about, well, there's all this AI craze. How do we become AI friendly in a way? And okay, I don't know the answer. What I do know is that there is an initiative still powered by Google, this Croissant initiative, for example, that tries to make data more available, more ML friendly or AI friendly by defining some metadata elements that could be attached to data sets. And this initiative, at least, is an extension of schema.org. So it's still working on that same basis, right? I have my data sets described using schema.org, and I add additional properties to make them more AI friendly or AI ready. Something to be aware. If you want to be AI friendly, maybe this could be the way to go. Maybe not. So that's what the linked open network could do for SDMX, or for the SDMX community in general, be a multiplier of the discoverability and accessibility of our data through these different portals that exist. But there's also things that we can do for this community. I mean, this community exists because there are users. There's a lot of use of it in academia, for example, or in other government organizations. And often, I think SDMX, our conceptual framework, can provide added value to this community. We have one of the strong points of SDMX is the semantics behind it. We have definitions, commonly accepted definitions of concepts. We have common code lists. I may want to say, if I have a data set, I don't know, I'm a research entity, I publish a data set, I want to say, I'm referring to this concept, this statistical concept. I may want to point to that concept. And what should they point to? To the SDMX concept, the SDMX definition. Can they do that reliably? Not so much. because in SDMX we don't necessarily have persistent URIs for objects, so it's difficult for them for people to reliably point to an SDMX object persistently and therefore make use of the information that comes from the SDMX standard for their semantic web purposes. And the thing is that we're not, in my opinion, very far away, if we wanted to as a community, to bridge a bit the gap between SDMX and the semantic web standards. I think we're quite close if we want to go in that direction. Because in the end, if I want to make my data available also to the linked open data community so that people can link to our data or our metadata, what I need to do is I need to make sure I have persistent URIs for the data, which I don't have. What I can at most do is give the link to the REST API, but I can tell you, our REST API in Eurostat has changed 3 times over the past 5 years. We're not trying to make it persistent, and well, everyone knows that, and no one is ever going to link to our REST API, most likely. And the second thing is that, well, okay, if people can link to our objects, that's good. It would be even better if we could return to them information in the format that they would expect. So an RDF format, or one of the different formats that are used by the semantic web community. And it's a bit the same thing. If we want to make our metadata or our data sets more discoverable using these semantic web-based platforms, we need to find a way to map our rich SDMX metadata to the ontologies being used by these platforms. I mentioned the DCAT ontology, I mentioned schema.org. There are possibly others out there. Those are probably the 2 that come to mind, at least in a European framework. And these are not things that are not achievable. If we want to do this, if we want to make URIs available for our objects, map our model to the relevant SDMX ontologies and make available, let's say, a mapping that would also produce information using those ontologies, this is all achievable. It's just a matter of doing it and wanting to do it. And there was already quite some work on this topic. I'm not claiming to be here and have some kind of genius idea. All of this was presented several times, and there were already initiatives to try and bridge this gap. We had, for example, a few ontologies developed for the semantic web, fully based on SDMX, where the basis was, let's really try to take SDMX or part of it and make a semantic web ontology out of it. The main 2 that I know of are the DataCube vocabulary, which is, by the way, a W3C recommendation. To be honest, I'm not sure if anyone is using it, though. I mean, it was last updated in 2014. It doesn't take into account any of the changes that came in 2.1, let alone 3.0. But it's out there. At some point, someone thought that it was a good idea to create an ontology based on the SDMX information model. We have StatDCAT AP, which is a bit different. It has taken this DCAT ontology I mentioned and added to it a few properties that are inspired by SDMX. And there was an input of the SDMX community into the creation of this DCAT spin-off, let's say. And there was also some, besides the work on the ontologies, there was some other work. In the past, there was a translation, let's say, or an RDF output of SDMX objects in the SDMX source library, which was then at some point removed because no one was using it, which is, I mean, something we need to be aware of. Why was no one using it? Was it badly implemented, no one knew about it, or just there is no use case for this? So something to be kept in mind. And then there are ongoing initiatives. We saw one very relevant one with Stratos, the SGDS, But but you have the SDGs, and then the we have to have acronyms that are less. We have to have acronyms that are less common, less similar to each other, that are more friendly to people with dyslexia or something. Anyway, but there you have this URN resolution, and for me, at least, the step between having a URI with the help of this URN resolution, where it just lacks a small component, but I would say we're almost there if we want to. And there is a work ongoing in the SWG to create an SDMX ontology that would try to integrate with other existing ontologies that already cover maybe parts of the SDMX standard. And this work is being done by Laura Vignola and Dani, who is also here. So at some point during the Q&A, if you want to make a comment about this, please feel free to do so. But there is work ongoing that could help us. And obviously, if we have this ontology, then we have kind of a mapping, and we know how to express our objects using these semantic web standards, and we could decide to do it. And we tried this a bit in Eurostat. I want to give you a bit of a specific use case, because if we are having the discussion, it's not just because it's not something that is completely theoretical, it's something that we had to face. And we have a specific use case where we tried to have this interoperability, and we saw a bit the difficulties or the challenges. And it was for our classifications. And up until mid-2003, we had in Eurostat a classification database, which was a bit old and was lacking some key features. It wasn't accessible via APIs, for example. The formats available and also the interface was quite old. And we decided, okay, let's make it nicer. Let's abandon the old software, and let's make our classifications fully fair. And we decided to go about it two ways. Okay, let's make our classifications available using SDMX, and let's do it also using semantic web standards, okay, as linked open data. And this is a project that we ran from 2021 to 2023, and in the middle of 2023, the new platform went online. So since last year, we have our classifications available both as SDMX and as linked open data. And this was quite interesting because it forced us to try and integrate the two worlds, make some mappings. So we took our classifications, we turned them first into linked open data using the SCOS ontology and the XCOS ontologies, which are two of the ontologies available to describe classifications or code lists, if you want, in general, from the SDMX perspective. And then we made a mapping from those ontologies to the SDMX information model, making wide use of the standard annotations created by the standards working group, so that we had a consistent representation of classifications, both in the linked open data way and in the SDMX way. And we managed to do this. We saw that it's doable. It would have been much easier, obviously, if this kind of integration was out of the box, and if I could just take my SDMX object and kind of export it using the SCOS ontology in this case, right? That would have made our life much easier, but we had to do it before we realized what would have been nice to have before we started. Okay, never mind. And we also made a bit of an assessment about, okay, how fair are we now with our classifications? And we tried to score a bit how the SDMX way of publishing things and the linked open data way of publishing things allow us to be fairer. And in general, SDMX fulfills many of the FAIR principles, but the linked open data approach does a better way of being fair for a few principles, where the only place where SDMX was a bit stronger was in the link to the actual data. It is much easier for me in SDMX to link a classification to a data set because I also have my data sets available in SDMX and described by data flows and DSDs that use those classifications. From the linked open data side, since I'm only publishing the classifications and not really the data, this link is harder to establish. But overall, let's say we were quite happy with the level of fairness we achieved with the two methods we used. And really, the main problem that makes SDMX not fully fair is really the lack of a URI. Because if we had URIs for SDMX objects, it would most of the columns, most of the items in the SDMX column would be compliant, I would say. All right, so some proposals for further work, and this is where I would like to have a bit your feedback. I would like to understand really, or to have a discussion within the SDMX community about our level of ambition when it comes to integration with the semantic web. I heard a lot about everything that's going on, all the new items that are coming in the standard. We had the discussion a bit earlier with Olaf. I'm always a bit afraid of, okay, we have new things, and new things bring new features, but also new complexity. And so would this new complexity, maybe, that an integration with semantic web standards, that the integration with semantic standards would bring, would it be worth it for the community as a whole? So I think the idea would be to launch a group or work package on the TWG, or we can also have it in different configurations, trying to discuss these items, trying to understand, okay, what are really the benefits of doing this? What would be then the priorities? Which ontologies do we want to integrate with, maybe? Which specific formats do we want to make available if we want to do this? And try to have, as much as possible, some concrete use cases that could clarify the benefits of doing this, so that then as a community we can say, yes, this makes sense, let's go for this. Or we say, no, it doesn't. We have other things that are more useful at the moment, and we put this in a closet somewhere to be rediscovered by someone 4 years from now in another SDMX experts workshop. So that's it. As I mentioned, it's more questions than answers, and yeah, I'd be happy to have your thoughts on this.
Okay, thank you, Luca. So you don't want any replies now on your last slide? Or?
As you wish, if you want to.
Yeah, okay, yeah. Any questions? Yeah, we have 2, 3. So.
Yeah, thanks, Luca. I mean, I think that Matt will have quite a few things to say about what's going on in the TWG, and including UNSD's collaboration with Google and schema.org. But what I'm curious about now, because you've looked into this, in SDMX, in the way we package our data and metadata, the separation between data and structural metadata, does it make it any more difficult? Because I'm trying to think through this. What I see is that you have a data set that doesn't have any persistent identifiers. That's not fair in itself. It's only fair thanks to its association with the structural metadata. But structural metadata is somewhere else. So how do you see this affects the discoverability of data and structural metadata? I'm just curious about that. Thank you.
Yeah, I'll give a quick answer to the extent that I can. As Eurostat, we are also part of the European Commission. We publish all of our data sets in the EU Open Data Portal. So there is a DCAT version. There is DCAT metadata about our data sets in the EU Open Data Portal with a link to the actual data. To be honest, that DCAT metadata doesn't go very deep. It tells you, okay, there's this title. I mean, this data set has a title. It's available here. It's available in this format. It's been published by Eurostat. That's it. Formally, it is fair compliant because you have metadata associated to the data using a standard, but it could be much deeper, right? If I could link that description to the data structure, for example, to the SDMX concepts it contains, then it adds much more information that would be available to make queries, to make things more findable, more accessible. But I cannot do that. I don't have a way to refer easily from in a persistent manner, at least, from my DCAT description to the structural metadata. So, at least in our case, we're already publishing our data in a fairish manner. But if we could link it to the SDMX metadata, structural metadata as well, it would be much richer and hopefully better for the user, who I hope exists for this use case. I'm not sure if I answered your question, Abdullah, but somewhat. Okay.
Yeah, and the next question, please.
Yeah, it's a compliment to what Luca has mentioned. Just I want to mention that starting from the SDMX object, from the structural metadata, like when we create the ontology, we start from the structural metadata objects, and this will help in the indexing. The semantic search engine will help the indexing, and it will help when a user do a search to better find anything you're looking for, starting from the reference metadata into the data. You know, so it's not the other way around, starting from the data side to the reference metadata. It will be starting from the objects that are already inside the ontology to the reference metadata. And of course, like if you're specifying a country for a classification, M49 classification, it will go from the reference to the specific country and provide back the data set that is linked through the reference metadata. So the work on the ontology or on the semantic web will start from the objects, not from the data. We'll start from the objects that are included in the metadata, and then we will use some of these objects to tag the database or the data in the database, and then this will be the link between both. And in reference to what Luca mentioned, we're working with Laura on SDMX ontology in the statistical working group, and starting from identifying the SDMX objects that we are going to include into the ontology. So this is a beginning. We have already an Excel spreadsheet with all the objects, the definitions, and so on, and partially linking to existing ontology, and the work is ongoing. The first is to identify. Second, to go through a peer review with the SDMX community. Third, create the pearls or URIs and then have it, and then convert the Excel file from Excel to RDF and get the ontology file publicly available on the SDMX. So we are at the beginning, but we have gone with almost all the objects in the Excel file, and we will move to the next steps in the future. And the question is actually what the semantic web will do to the SDMX community, not the other way around. So we start with the first part of it because it will do a lot, but we need to help ourselves first by finishing the ontology, make it available, and then start using it. And then the semantic web will help us to better findability, accessibility, finding for users that are interested in the topic. Thank you.
I couldn't really find a question there. I was just nodding. So yes, I agree in general with what you said, Danny.
Okay, just okay. Just a quick question. Sometimes we find that these same SDMX objects are, for example, located and published in different endpoints or in different locations related to the GDS development project. How then to tackle the specific location of one object and if it is updated compared to another object? I don't know if you follow me. So if he uniquely identifies it, how to ensure that it's this one and not this one?
Yeah. That's a very good question, and it touches upon, I think, one of the difficulties in SDMX, that you have objects that are replicated across different registries. But okay, I think Matt has already an idea of how to solve it. I would have probably something, but I think you told me, so it's probably the same.
This is what the SGDS actually solves, because the idea is that, yes, metadata is replicated, but there's one kind of authoritative source. So the SGDS basically says, this is an agency that has this metadata, and the endpoints are prioritized. So you kind of know that if you find a duplicate over here, that's just a duplicate. This is the actual original source. And if I can continue with, just a couple of points. So on your persisted URI, so the TWG is doing two things. Number one, we are in the process of registering the URN with the authority that you should register URNs with, which is IANA, to say this is an official part of it's an ISO URN, if you like. And part of that registration process requires us to define how the URNs are resolved. How are they resolvable? Because this is part of the registration process. And then the next part is using the SGDS to tackle this problem. And you'll be overjoyed to hear this is exactly what we're talking about on Friday in the TWG. So we'll be discussing this exact topic. Hopefully we can look to close this gap.
Perfect. I think Edgardo had the last question, and I think we will need to move on.
Yeah, thank you, Luca, for the excellent presentation. Just to complement, another two things that SDMX has to give or provide to the link open data or semantic web, said by the DDI community and the link open data community, not by me, is the registry specification and the standard API. Mm-hmm. Because these are two elements that are part of SDMX standard that comes to complement the resolution of the URN to a URI. Because once that you have the URI, you will know where to query, but also how to query, and you will have also a response that will be standard because it's specified in the registry. So I think that this closes the gap to be findable.
I can only agree with Edgardo once again.
Okay, I think this was the last question for now. So thank you again, Luca, and some applause. So the next presentation will also focus on the data point model and the SDMX, but this is, as I understand it, a more real implementation of the interoperability between these two standards. So it's done by Mari Rusev, original from Bulgaria, earned his bachelor's degree in physics from Lafayette College and a PhD in physics from the University of Vienna. He also holds a master in mathematical finance from the University of Oxford. And he, since joining DeFine in 2018, he has specialized in data modeling, financial analytics, and software development for regulators, contributing to various regulator projects such as the redesign and implementation of risk analysis systems and the creation of AI-assisted reporting frameworks. His expertise extends to areas such as data modeling, FinWeb, asset encumbrance, own funds, liquidity, and interest rate risk. Mario is from a company called DeFine, which is also a company that we are using in DCB in different projects. So, yeah, you can.
Thank you, Ole. Hi, I'm glad to be here, and it's a great honor. I'll just say two sentences about DeFine. We're more than 1,000 people, and over 50% have a PhD either in math or physics or chemistry, one of the sciences. And usually we deal with very complex problems or very computationally challenging problems when you have to do some complex software or complex analytics or mathematics. So the presentation here is about SDMX and interoperability, and I think Fernando made a very good introduction to the DPM and to XBRL. I will just take a look back, and I will not go into details. Most of the time I'll just present key results from various projects that we did. And that's more or less another approach to a table of contents, just looking at the big picture of why you would want to use SDMX or XBRL or any other format in this case. You would start from typically either a complex monetary policy or let's say a question that you have. I'm not going to go into politics, but the obvious question now would be, what happens if you have a supply shock? Can you model, can you forecast a supply shock into your statistics, into your data? And can you predict it? What can you say about it? I'm not going to say anything about forecasting. I'm just going to mention something about nowcasting at the end. But just keep in mind this question at the end. So if you have such a question, normally what you do is you have your monetary policy or a strategy that's right behind it, and you base this on certain statistic, or you base this on a certain analytic. Either it's an analytic software or it's a statistical data set, and you just do some statistical metrics or measures on it. But if you want to do this, you need a technical data architecture that's supporting all the statistics. Normally it's either big data or very large data sets when you want to do some backtesting on it or other things. And then you have some software that's surrounding this. So each of these slides, I have 4 slides with more or less key results. The first one would go around, can you find a transformation that's linear enough between SDMX and almost any other standard? The short answer is yes, but there's caveats. I can think of 20 of them. I'll give you 5, more or less. The other slides go into a sample data architecture from one of our projects that we did that is very, very highly performant. And I'll try to convince you why you have to take into account very highly performant systems in order to do highly performant data, in order to do highly performant systems or software, such that you could do complex analytics or complex statistics on it. So in the end, you want to answer a very complex monetary policy question. So going into the SDMX and XBRL. Now, Fernando mentioned a few things about the DPM. I'm not going to go into the details. I've only highlighted a couple of things that I think are important. Now the version is about 3.4. There are several models that go beyond that. The interesting thing about these versions is that now you have interest rate risk models into the new DPM versions. And these interest rate risk models are forward-looking. So you have data which is basically a simulated balance sheet of a forward-looking data. But the balance sheet is for DPM versions that are typically backwards-looking. So you're giving a data into a particular time interval, and you're saying this was the amount of my LCR or an NSFR at that point in time. But now you want to combine this into a simulated forward-looking version of data, which, when you think about it, it's completely 2 different underlying systems. So one is simulating future cash flows, the other one is something that already occurred. And how do you combine this into a DPM? It's not very easy, but the European Banking Authority did their best, and they have some model of it. But when you sit down and think about how can you transform between any format to SDMX or to XBRL, you find out that at the end, you really want to do a transformation between the hierarchical structure of the DPM and, in this very simplistic, right? But it's much more complex behind the picture. But between the hierarchies in the DPM and the hierarchies in the SDMX, what you find, it's a nonlinear transformation, so it's not always possible. So it's possible under certain conditions that have to be not ill-defined. And what you find is you could do the same thing also for CSRD and ASRS. For ESG reporting now, they're doing it in inline XBRL. And then you might ask yourself, why? Why is it so difficult? Or why do we have two standards? Can't we just combine them in one? And if you look into the details of each of those things, how SDMX operates, and you all know how, and how DPM operates, and I'm pretty sure most of you also know how, you'll find out that that the DPM or XBRL is always based on a context reference. So you're taking a data point, and you're defining it based on dimensions onto a certain metric, right? So into a certain dimensional space, or 1D space. And this metric could be notional amount, it could be carrying amount, it could be anything. And this is always, this is an artifact of the idea that you have certain functional people or certain functional teams that are sitting down together, they're looking at a table, in an Excel table, and they're saying, this is my column definition for columns. These are my rows definitions for all the rows. On where they match, I get a data point. And this is how it's typically done for not just for the DPM, but for many other formats. You want to define it based on a legal note. In reading this note, you end up with certain row and columns definitions. Now, that's a bit of a problem because the SDMX works in another way when you think about the MSD. You need to define the hierarchical structure of the table itself, which is fine. You can also do it in the DPN. I'll show you we did this pretty efficiently. But the real problem with that is it starts to get inconsistent. Now, one specific example is if you just look at the code list in SDMX language, the code list for counterparty sector in the DPM. If you look at it from the FINRES perspective and from the CORES perspective, you would see that counterparty sector for COREP includes investment funds, but not for FINREP. So in your balance sheet, investment funds fall into another category. And then you start to wonder why. Like, why do people define it this way? And in the end, you'll find out that there is a certain particular functional definition that has to do with collateral groups and how you define your collateral group based on the COREP definition. And then you explain yourself why those different things work this way. But in the end, what I want to say to you is the DPM is there because there's a lot of functional definitions behind it. So you look at the XBRL and you're not just looking at a table, but you're looking at a functional definition itself. So you're taking a data point, you're saying, this is how I define this whole thing. And it's a functional definition of different dimensions. And it's, in a way, it reads as a text. Whereas for the MSD, you just need to define your irregular headers, if you will, right? And then the question becomes, does not work. Okay. Can you do this? Can you find such transformation? And the short answer is yes. It's not easy. I will show you something that we did that we typically do. We found a pretty nice transformation for XBRLs that can visualize any data format pretty generically for XBRL and DPM. We could do it for IOPA, I could do it for ESG, for ESRS, you name it. It works pretty generic, and the reason it works is this. So this is just a very simple process that I usually keep in mind when I want to design a very highly performant software that has a very good business view on it, or a good business use case. So you would start with your identification of business workloads. So you basically want to ask, hey, what is the business case I'm trying to solve here? Remember I told you at the beginning, how do I model supply shocks? Or all of you know the saying, the regulatory bodies are doing too little, too late. So it's pretty much the same thing. So you want to solve a particular business idea, a particular business problem, and what you want to do is you take your requirements, methodological assessments of the quality and quantity of things you want to do from the business perspective. If you're doing XBRL, this has to take into account the data model behind it. And then what you get is you get the ranking list of operations, which is typically what you do when you define a data model or a database. You're basically saying, these are the things that are very important for me in my software. This is what I want to be highly performant, and this is where I could do a trade-off. Once you have this, you could start thinking about data sizes. If you're using a database, sharded clusters or replica sets, do you do a relational one? Do you do a data modeling? Do you do a NoSQL one? If you do a Mongo, do you do it in an OpenShift cluster? Do you do it in an open cluster like AWS or something else? So there's a lot of details that go into this, but you have to ask those. But it all starts with this ranking list of operations. So basically, where can't you just really do trade-offs on your business operations? And once you have this, then you can always get some patterns. And there's a couple of points that I have there, but you can all read them. And it's the point that I'm trying to make here is, if you go the relational way, you will see that sooner or later, if you want to extend on your model, if you're doing an SDMX model or you're doing some other model, the thing's going to blow up. You just add up new tables. So if you have a highly computational complex problem or a functional problem you want to solve with a relational data model, what you do is you just add more tables, right? Or you just add more columns, or you just add more data. That is not always good. It works most of the cases, but once you start handling very large data sets, and once you start asking very complex problems that are statistically significant and statistically difficult to compute, then it doesn't really work anymore. So that's when you want to consider something like never recompute what you can pre-compute. What I mean by this is, if you take any data model or database, you will find that if you do a pre-computation on the right, it's much more efficient once you read the data and do your particular linear transformation in it. So you can do some pre-computations. For example, Twitter does this. In their Mongo database, you would just basically do some pre-computations, or you would link it, or use other methods. And then you would want to make a list of most frequently used queries and things like this. So once you do these two steps, then obviously you have to consider things like telemetry, logging, and so on. But what you really want to end up with is a model that's clean, that's based on a business use case, right? On a business view, what kind of business problem I'm trying to solve, in a very flexible architecture or a data model, which SDMX is, to be honest. It's very flexible, it's very generic. You could use it for many things. My personal opinion is that SDMX is the architectural view on statistical data. XBRL and DPM are more of the functional view or the business view on statistical data, and you really need to have both. You can't just replace one with the other. I mean, I know this might open some questions, but I'll just leave it there. So if you do these three things, here is one example. This is a real project, one of the projects that's also production running. It's a software that is container-based on-premise. It has no database. It stores absolutely nothing. It accommodates any XBRL format. In any, like you give me any format that's XBRL or DPM, no matter what taxonomy, no matter what version, no matter when, no matter in how many dimensions that is. For example, some of the dimensions are also open headers. So open dimensions, for example, probability of default. And they have regular headers that can be a bit weird or too big, for example, in the template 18 of FinRep. And it would do it pretty efficiently. So it would generate this table. It would visualize it. Basically, you could also do it with SDMX. It's more or less straightforward. If you want details, I have also, I think, one slide which is a bit more detailed. But it does all of this in 6 milliseconds. And the cool thing about it is that you can click somewhere on a data point, because the data points are also points in this coordinate systems of irregular headed tables, and you could visualize a time series for all data points in all time. And this does accommodate changes into taxonomy, into versions. For example, you click somewhere, you could see changes. You know that the data point or the table itself may have changed 10 years ago or 3 years ago. And this accommodates this. This knows it's exactly that same data point. And you can obviously frequency adjust it, because you want to find out really how the graph looks like into different sampling intervals. So it's really adjusting the sampling rate. That's what I mean by frequency adjusted. Right, and the funny thing about it is it does not work for any DPM. It also works for any taxonomy. Some of the taxonomies of this particular country where the software is based have many tables as one table. So they define, for example, risk balancing capacity of 10 tables that you define as one template. No problem. So you can generalize this approach to work with any dimensional tensor. So, and it's still 6 milliseconds, even for large exposures which have open primary keys. You could paginate it. You could go into the thousands or millions of datas into it. And the reason I'm showing this is not to show off the software, but I'm trying to convince you that you really need this, okay? And I'll try to tell you why you need this. So if you have a data point, let's say, and you have a very high performance system behind it that could give you any time series for all time into any sampling rate in a relatively good time response, then you can do then you can answer interesting questions. Now these plots or these pictures are pictures that pretty much anyone can do from the mathematical standpoint. They're not too difficult. I'll try to argue a last word of why I asked the specific questions in the beginning. How can you model a supply shock effect? So obviously anyone can do PCA on multidimensional tensors. So what you would do is you would cluster data, you know, that the DPM or the any other format would have very high dimensions in terms of the positions that you are reporting. This could be anything in Corep, this could be anything LCR-like. And you can PCA on it, so you can reduce the dimensionality, and then you can do clustering on it and find where the distance metric is maximized. So basically, what you want to do is you can explain what positions are having the most correlation into a dimensionally reduced coordinate system for my initial problem. Then you can also do visualizations and dashboards with all the GraphQLs and all the different graphs visualizations, how many clusters you have, are they symmetric, how central they are, and so on. And then you can also do some stress testing. This example here is from a liquidity stress test that we are doing, by the way, real time. And we don't need any additional data. This is for a particular country. And normally what some particular institution did is they asked for additional data, and they also then now this liquidity stress test from 2019 is employed into the SREP, which is great. But we also find a way to do this real time. But in order to do this real time, without asking for additional data, you really need to have a very high performance system or software behind it that would basically give you those time series responses on the order of a second or a second and a half. And if you want, because we are all humans, you would want to visualize the results, so into either a tabular form, or you could visualize it into a graph, and this would take about 6 milliseconds, either 6 milliseconds or a second and a half for the plot. And then you can also do correlations. If you've done a bit of game theory, you probably know what Shapley values are. And then you can do even maximal correlations, or you could do standard Pearson correlation between data points. Now, all of this does not solve the problem. If you want to look at supply shocks, or if you want to solve the problem of we don't want to do too little too late, this is not going to solve it. This you can do on pretty much any software that's good enough, but you don't really need very high performance software on it. What you really need to do, and my argument for this is codependency. They're not necessarily metrics because they don't fulfill all the properties, but you want to do codependency, or codependence, some might say. And you want to do nowcasting. What you basically do is, there's generally a problem in econometrics when you look at correlations. The problem with correlations is that when you look at different, for example, Pearson correlation, you're only handling linear correlations between variables. That means if, for example, you look at counterbalancing capacity for liquidity stress tests, or you look at whatever, anything that changes in value within a certain amount, obviously your counterbalancing capacity is going to reduce by the same amount. It's linearly correlated. You're not gaining any advantage. You're still too little too late. What you want to do is find a metric that is maximizing a codependency. For example, mutual information, which means, are you gaining uncertainty by knowing another random variable? And you want this to be lagged. For example, the obvious case is if you look at satellite images from parking lots for supermarkets, you could pretty much find out what how much the company made for the next month almost instantly. I mean, you can also correlate it, but you don't even need to look at market reports anymore. So you could do also alternative data on it. But my point here is linear correlations or Pearson correlation does not solve this. You have to look at codependency, and you have to do it in a nowcasting matter, such that you can react. It's actually not our idea, it's not my idea. It's exactly what you do with earthquakes. It's pretty much the same thing. Now, if you want to model atoms with correlation, it's a bit different, but it's pretty much what you do with earthquakes. Right, so that's about it for this. And I just want to take a look back again at the big picture. We started with a complex problem. We want to model supply shocks, for example. We want to not be too little too late. Then we would like to realize that we need a very efficient statistics. So we want to do a very nice, I'll just call it nice, codependency onto it that would look at nonlinear correlations. And we would want to do it in a nowcasting way. We also want to take alternative data. You want to look at all sorts of billions of parameters, if you want, the billions of data parameters, and you want to do a model on it. You want to really do a theory on it. You don't want to do a simple neural network with thousands of free parameters. That's not going to work. So if you do this, you might find that if you want to do a bit more complex statistics, then that are a bit more useful, then you really need a good system behind it. And then I came up with these 5 points that is pretty much the take-home message here. So standards are different, and each of them has an equal value. XBRL, DPM, ESRS, they're very important, and you can't just simply replace all of them because they have a different perspective on how you view data and why you view data. So it's nice to understand them and look at the benefits of each of them, and try to find a system that's taking all those benefits to a unified solution that's going to bring you the best for your business use case. And that means that the different institutions have to work together, right? So the second one is never recompute what you can pre-compute. What I really mean here is you really want to put more substance in your data and not more methodology. For example, if you're doing anything with geographical data, numerical time series that are stored in Mongo, then you would want to pre-compute certain metrics or aggregations or whatever into your data while you put the data into storage and not afterwards, because that's very, very efficient. We're talking here really less than a millisecond for read times. Then highly performant and efficient systems are only achievable when you really think about how you want to store, how you want to functionally store the data. So you take first a look at the business perspective and what kind of business problem you're trying to solve, and you really orient the data model or the data storage around this perspective. And then the other one is the statistical approaches. They need to be able to adapt quickly. So you would really want to be nowcasting. You would want to do real-time processing of data, not just simply report data, but really understand data and try to do these statistics on the data real time, because that brings you the most benefit into trying to solve complex situations. And then anyone who's read Tufts, you would see that there's a specific metric that's called data to ink ratio. And I'm also, I've done this as well, but sometimes you would have a nice plot or a nice graphic or a nice looking dashboard, and you'll think, wow, that looks so great. But that's very subjective. So nothing beats coherent data. So if you have coherent data that's letting the data work for itself, for the graph, and there's no need for hundreds of colors or to over manipulate the graph. Coherent data is really that's what's bringing the most value into a particular statistical process. So that's about it. Yeah. So if there's any questions.
Thank you, Mario. Thank you very much. Applause. So, any questions? Okay, I have one. The application you are showing, what's the UI for that? Is that the browser, or what kind of UI do you have?
It's unfortunately not public.
What, sorry?
It is not public, but it's owned by a particular national authority. And as I said, there is no storage, but the cool thing about it is that you don't have to change anything on it. Like, there could be a new taxonomy or a new version of the DPM or any other national taxonomy if you want. You change nothing, it just works, because it's just so generic that you can just let it run into some cloud, and then you just visualize your whatever you want to visualize.
Okay, thank you.
Yeah.
And still no questions? No. Okay. Then yeah, thank you, Mario. Then the next presentation is from Pedro Carranza from OECD. He works at the OECD as a Stat Suite technical lead, and for the last 6 years he has been involved in the implementation of SDMX tools. Pedro is member of the SDMX technical working group, and he's now leading the SDMX formats task force. So you have 2 minutes. No, okay, go.
Good enough, yeah. So yeah, my presentation is light, last one of the day, so I think we can all follow. So beyond SDMX, two key barriers for system integration. So the nice image here, that's me asking for help. So this presentation, it's not going to give answers, it's questions. Also, compared to the other presentations, my angle is on the interoperability about in the existing implementations rather than the standard. All right, so a little bit of context how I got here. So back in 2022, there was a presentation in Mexico on the SDMX expert workshop by Fadila on the results on the interoperability task force. There they did a study and presented what was concluded after a survey of how the existing implementation should enhance interoperability. Now fast forward to 2024, within the DOSTAT, in the SISCC community, we started to create our work plan for the next 5 years. And two key components that we focus on are performance and scalability. Out of this, one of the deliverables is the DOSTAT suite target architecture. I've seen in many presentations an exchange with colleagues that are working on implementing tools for SDMX, that it seems that most of us are going towards more modular systems. I see keywords on microservices, domain-driven design, and so on. And this surfaced the opportunity to, that it was a really good point to maybe reach out to other implementers to see a potential enhancement of interoperability of our existing systems. So what we wanted to focus here, it's how we can improve the interoperability of our systems to improve reusability, and of course cooperation among the tool producers. I'm sure we all hear this many times. So we reach out to two of our key partners, so BIS and Eurostat. And the idea is that we also can improve the interoperability of our system to improve the user experience, especially when working in multi-platform context. So you have different tools installed to address different problems. So I'm focusing on two key aspects, two key barriers for system integration. I hope they are really precise, maybe not so easy to solve, but I'm asking to understand motivations and see if there's interest to focus on this. So defensive disclaimer and credits to ChatGPT. There are some incorrect names and logos. But yeah, again, this is me. All right, so the first one, authentication. So what is authentication? Basically how you log into a system, right? So looking at the different partners, we try to address what is the current landscape on how the system use protocols to log in. So these are the ones that I identified. So this causes that users are required to log in multiple times if they have the installation within the same organization, so on, right? What does SDMX says? It recommends HTTP basic authentication, and the question is this secure enough for the policies of your organization? The second one is authorization. So what is authorization? Basically defining what a user or a group of users can do in the platform. Also in the landscape, there's multiple custom implementations. There's, for example, in the case of the DOSTAT suite, we use the NSI web service done by Eurostat, where we managed to break this barrier through plugins. But this is still not fully interoperable with all the landscape of implementations that we have seen. So what this brings is that it's very complex to enforce consistent permissions. You really need to have an authoritative body that keeps in sync these rules. And this can lead to security gaps and unauthorized access. So this can be really critical. So I would like us to take a little moment to reflect on this question and admire the nice image and how the SDMX systems could get happy. Can we all benefit from a single sign-on and a single user rights management? All right, so few things that what can we do, and this is an open question. There's no answers here, but this is really to get a feeling on what could we do. So for authentication, could SDMX adopt or recommend a secure common standard? So there's many out there. Or should we just let this work for the implementers to figure out? There's multiple ways to do as well. In the other side, in the authorization, do we also make it part of the SDMX? For example, adding to the REST API definition, is this user group authorized based in these actions and these specific artifacts? Or any other, we lead also to the implementers. The use case that I showed through plugins, through interfaces, there's solutions from software perspective, right? But the question is, if I'm going to build or reshape my existing implementation, what should be the path or the recommended path to take so I can take in consideration everyone else, so the implementation it's more in line with what exists. So with this, thank you for the time, and this I conclude with that. Thank you.
Thank you, Pedro. Anyone who want to ask a question or comment on the questions that Pedro had? Yeah, of course, Xavier.
Thanks. No, very interesting. Sorry, just a quick one, and it's really a question to everybody. Also looking at Matt. And it's about we have already like data flows, and we can, for example, relate data providers to them. And I was wondering if, in this context of authorization, should we also allow to establish a link between data consumers and data flow? Because I guess this could be of interest in the context of authorization. And of course, organizations like data consumers, I guess, now that we can also have like sub-agencies, sub-organizations, it could be very granular. Just open question, I don't know. Thanks.
Anyone who wants to grab it? Oh. Okay. Do you have a Pedro? Pedro? Would you have?
Yes, I think maybe we should discuss this. But what I would say is it would be interesting as well to discuss further the API for authorization, so you can actually externalize it if you need to, but you can have it internal if you want. But what I would say is, because SDMX, the structural metadata anyway is essentially a graph of objects, it gets a little bit complex if you suddenly have like a private artifact down here, which is referenced up here. So we need to think very carefully, I think, about it. But yeah, this is definitely something we can discuss within the TWG.
Any other questions? I could also maybe ask. Oh, okay, we have here.
Yeah, maybe just one comment on the authentication. I think we should remove the HTTP authentication from the standard, because indeed, I'm sure most of or probably every organization from a security perspective, they would not support this anymore. that this is really outdated, I think. Now, the question is, do we include another more secure authentication into the standard? I think what would be good is maybe to have a quick survey. I mean, we did this, I think, already amongst some of our organizations, what are actually authorized standards, because at least from the BS perspective, our corporate security has very strong views on what to allow and what to not allow. And maybe it would be good to get an overview. In particular, we typically have reference implementations which we develop together with our corporate security, which are then authorized from an enterprise architecture perspective. So we need to follow this. We are quite constrained by this, yeah. So, yeah, this is just regarding your first question, yeah. Mm-hmm. Thank you.
Yeah, just maybe to add to that, I forgot to highlight this particular use case because not complaining, really just to show that it's not an easy task, right? There's internal policies why not moving to a more generic standard. So I understand that it might be an easy topic, but complex politics around. Yeah.
I think there was a question from Jens.
Yes, maybe an additional aspect of interoperability would be linked to what you said earlier. We are all looking into making our service more modular. So an example would be to have a service that deals only with structures and another one with deals with data. Of course, you can expose it through an API gateway or other technologies as a single SDMX API to end users, so they don't actually see that behind the scenes. You have two different modules for doing this. But the additional challenge that you have is synchronizing the information, what is managed in your structure database and what is managed in your data database. If you add new structures, maybe your data database needs to be informed about this. So we need a mechanism also to have the services talk to each other and notify them about changes and things like this.
Yeah, so just as a food for thought, we are proud in SDMX, right, that we are technology independent for the, let's say for the data queries is the most common example. It's like I have an API, a query for data. I don't care if the data below is SQL or Hadoop or Oracle or whatever it is, right? And I think something similar we should employ here because there are all reasons for, Eurostat having EU login and whatever we have in the ECB, I don't even know. On the API level, I think we could do something to at least have a REST pattern that we say, okay, whatever implementation you have below, at least I can query the metadata to say, am I allowed to access this serious key? And then it's up to the organization to map that to their backend, whatever they use. But at least I can query, let's say, the registry to say, what do I need to access this data flow, or what do I need to access this partial key? And I can get back at least a reply. It's like, okay, you need an account there, and you need at least this security protocol. And at least it would abstract a bit SDMX from the real implementations, and we could still give qualified answers and maybe at least facilitate integration. I don't think we can solve it on SDMX level. Just as food for thought for the discussion.
Yeah, just to add on this, I had similar reflection. There's many technologies that we interact with in the backend, for example, and they all use different sign-in protocols, access rights, and so on. But I guess the idea here is for the end client. How do we make the life of the end client easier?
So, any other questions? Okay, then thank you, Pedro. I don't know. I mean, now I maybe trying to change the procedure on the way. We had more questions than I said in the beginning. So I don't know if there's anyone who has questions for any of the other presenters before we finalize the session. No, everybody wants to move. Understand. I don't know what to conclude on this session other than we need the interoperability. It's complex, and we will be talking about this for many years still. So there's many standards. So have a nice evening.